Welcome back, my dear friends. A very good morning, good afternoon, good evening to all the participants. And the course name under MOOC-NPTEL is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sangupta from IME department at IIT Kanpur. So, as you know, the main three areas: averaging techniques and forecasting, multiple linear regression and time series. We are covering averaging techniques and forecasting, and it will continue. Once we go into regression, I will inform you accordingly. This is week 1, lecture number 2. Now, if you remember, I had mentioned very categorically that even if the coverage, which I will come to in the next slide, the coverage which I state in the slide and I read it out in the lecture, recording lecture, may be 3 or 4 topics, but as the lecture progresses, you may find that the overall coverage may be only few topics. So, those changes are being made in the actual slides. So, try to balance this information which what you see in the video lectures, because the lectures which you will get through NPTEL office would be complete in all respect. So, in the first week, first lecture, we had covered different examples, one being production of grains for India from about 1950 to 2020, and we basically deduced many things from the pictorial information. The second example we considered was basically temperature in Fahrenheit at New York Central Park for a number of years for each month, and we had lot of information from there which we discussed. So, what is the coverage for the second lecture of week 1? Again, with the caveat that we will cover, and whatever is to be done, we will change the slides accordingly. We will consider the different concept of quantitative and qualitative techniques for forecasting. What are the steps for forecasting in general? So, there may be more sub steps for different type of forecasting techniques, but we will highlight that. What are the types of forecasting which used? What are the numerical measures? How you measure your forecasting technique is good or not good, or is excellent and gives you good results. So, whether you are trying to find out the average, the variability, or there is cyclicity, seasonality, trend is increasing, trend is decreasing, and we will basically understand the metrics for forecasting, what are the different numerical formulas for the same. Again, there is no derivation, just the application of this different type of models. Now, forecasting types are basically qualitative one and quantitative one. So, obviously, this course being more for quantitative, our main emphasis would be on the quantitative techniques. Now, when I talk about the quantitative techniques, there are a lot of methods. So, the time series part, which I said in the first lecture in details, we will consider the third big part of the whole set of MOOC-NPTEL series of lectures. And if you know, the total coverage for all these 3 topics, forecasting, regression, time series is about 30 hours. So, we will consider time series as one of very good method for quantitative techniques. Now, the main idea which I will start saying for the time series is that their variability is taken seriously. Variability means, because for time series, the concept of autocorrelation, heteroscedasticity, homoscedasticity, non-autocorrelation, these points which I am mentioning in simple plain English would basically become clear as we proceed and understand the problems. And in the exploratory studies, we use different methods, different techniques, one being the forecasting set of techniques which we are using, and obviously we will also consider the concept of linear regression. So, under multiple linear regression, even the word is very generic, there are different type of models, lasso models, quantile regression, then nonlinear regression, then you have also the logic profit models. We will try to cover them as we proceed for the next big part, which is basically regression. And another qualitative one, that depending on the amount of experience people have, brainstorming, the concept of Delphi method, using different type of experience, different type of information sharing from experts, you basically try to come up with the ideas of qualitative forecasting. Now, having said that, obviously people will rely on the quantitative techniques, because the quantitative techniques would basically be based on sound mathematical models, where it will be proved and considered to be sacrosanct depending on the set of persons. So, persons may change, but the models would basically remain the same depending on the assumptions you are taking the models. While in the brainstorming, Delphi method, expert opinion, also you are taking the advice or the information set from people who have been in that line, who have been utilizing that information, who have that knowledge. So, none of them are the best in general sense. Obviously, we will lay more stress on quantitative one, but having said that, also remember the concept of qualitative techniques, which I had mentioned. I will write it down here. I will use the red. So, you have expert opinion. So, marketing manager would be asked that what would be the sales for a particular product. Say for example, some bulbs, LCD, TVs, maybe cars, maybe motorbikes. So, brainstorming session can also be used. Depending on the experts who are there. The experts may be, say for example, for different zones the marketing managers are called, and they have a meeting with the general manager of marketing sales, and they basically pass on the information, get the information from different zones, different states. If I am considering all the different states and union territories in India, information is taken and then analyzed. Then there is the concept of Delphi method, where ideas basically are analyzed depending on different scenario. So, you also do the scenario analysis. So, depending on different scenarios, what are the situation? Say for example, the input costs increase, maybe by 5%, maybe by 10%, maybe by 15%, or the cost of transportation increase, or maybe tariff increases. So, depending on the different scenarios, the analysis are done, and these qualitative techniques are utilized along with the quantitative techniques to come up with more robust, much better forecasting models. Now, even though these concepts which I just mentioned verbally, the expert opinion, brainstorming, Delphi methods, scenario analysis, they would not be discussed in details for this course, but someone can pick up and have an idea of these different type of qualitative techniques from any good book, and understand how both qualitative and quantitative techniques are utilized for better and much more comprehensive forecasting technique. Quantitative forecasting can be applied where three conditions exist. So, let me highlight. So, the three conditions are information of the past data available. Say for example, I am selling soap. So, obviously, and I want to predict what would be the sales of soap in, say for example, the state of Gujarat in the month of, consider, December 2025. So, today being June, obviously, I would technically assume that the sales of soaps for the past data for January, February, March, April, May for 2025, as well as from January to December for 2024 is available. So, based on what is the trend, what is the average value, how is changing, I can predict that what would be the sales for that particular brand of soap in the state of Gujarat. Or say for example, I am trying to consider what is the amount of sales or in volumes or in numbers for air conditioner in the state of Chhattisgarh. So, obviously, the sales of air conditioner would be more during the summers and definitely less during the winters. So, if I want to find out, say for example, what would be the sales for such air conditioners, depending on the tonnage, it can be 1, 1.5 split, then tower ACs, box ACs, whatever. So, let us take one AC, see for example, for tower AC, and which are basically used for different type of showrooms, in halls, in marriage halls, birthday parties. So, if I am considering for the sales of such ACs in the month of May, June, July for this year, obviously I should have the corresponding data for 2024 and if possible for 2023, because sales of ACs would be much higher just prior to the summer weather starts. So, which means that there would be some seasonality, the word seasonality I am using for the first time, there would be seasonality in the sales of this product. Or maybe I am trying to understand what would be the sales of woolen garments in the state of, say for example, Assam. And obviously, the amount of woolen garments of particular brand for a set of either for the kids from the age of, say for example, 5 to 10 I want to find out. So, obviously, it will be the highest during the winters, maybe during the months of November, end of November, consider November, December, January. So, for this year, December for 2025 and January for 2026. So, you have the data for corresponding one for 2024-25 and then 23-24. So, obviously, I can find out that there is a seasonality of the sale of this product, which is woolen garments, similarly as they were for sales of such products for the ACs which I consider. Also, there can be cyclicity. So, there is difference between seasonality and cyclicity. Seasonality technically can be for a quarter, can be for yearly, can be bi-monthly, can be after each 6 months semi-annually, depending on the type of products. So, for the examples which I gave for woolen garments, or maybe for the case of ACs, it's basically cycle repeats after each 1 year. But now, say for example, I want to consider the sales of gold ornaments in the state of UP during whole year. So, if I consider that, there it does not depend on whether it is winter or summer, but if I consider during Diwali, during Dashera, during Dhanteras, or during some festive occasion when the marriages are being held. So, obviously, I can understand that the cyclicity, how it changes. So, it is not basically, if I consider the whole year, the cyclicity or seasonality, season factor is not there. It is more basically a cyclic depending on different type of festivals. Similarly, if I consider the price, I am now going to the concept of price of, say for example, coal or steel, there would be some cyclicity, so which is being repeated. Similarly, I can find out for the cyclicity of oil prices. So, these examples which I gave were basically information of the past should be available, and when I am talking about the past, these set of information about cyclicity, seasonality, trend mean average should be available. This information can be quantified in the form of numerical data, as I said, and as you would have seen in the pictorial diagram for the grain production for India, or say for example, the temperature in Fahrenheit for New York Central Park. And the third condition is basically it can be assumed that some aspect of the past pattern will continue in the future, which is very important, which means the cyclicity, trend, variability, whatever it is, we assume it will be repeated. So, if you remember the diagram for the production of grains in India, we had discussed that to be divided into two time frames, 1950 to about 2002 or 2000 consider, and another was from 2000 to 2020. For 1950 to 2000, the average trend was there, considered it is fixed and it was increasing at a certain rate. While for the next half or next block of time period, starting 2000 to 2020, the average value was much higher. If it was increasing at a fixed rate, but the average value was higher. Maybe per unit time its increase is same, but in this case we see that the average values was changing. Or say for example, in the same diagram, if you remember, because the slides would be available with you when you are going through these lectures, please do check that the variability for the second half of the data 2000 to 2020, the variability for food production or grains in 10,000 tons in India was much higher, because that change could have been due to season, to do some weather fluctuation, maybe different land irrigation was a problem, maybe rainfall was an issue. So, all they can be different reasons, or maybe cost has increased for agriculture. So, obviously, people were not that enthusiastic to basically utilize the land for the cultivation. Similarly, the more so in the case if I consider for the temperature. So, we have across the years and across the months. So, we assume that the month wise data would be repeated. So, if you consider that concept or information from the past being more applicable for the future, we can see that we are much more confident in stating this third point for the temperature case rather than the production of grains. So, you can find, understand the data, talk about cyclicity, talk about seasonality, talk about trend, and talk about how the past data set can be utilized to basically arrive at some conclusions which I am stating. And again, remember, till now I have not started the solving the problems with the numerical values. Now, what are the steps to be followed in forecasting? So, these steps I am just stating qualitatively, we will go into details as we proceed. You define the problem. So, when you define the problem, you basically find out what is to be forecasted. Is it rainfall? Is it production? Is it basically flow of traffic? Is it basically price of a product? Is it basically, say for example, humidity or temperature? What do you want to study? So, you basically define the problem, and once you define the problem, you understand that whether the type of concept of cyclicity, seasonality, trend, variability increasing, variability decreasing, variability being constant, what concepts are applicable for this data set, whatever the different examples I gave. Then basically you once you basically have defined the problem in all its nitty-gritties, in details, you gathered the data. When you gather the data collection, say for example, for temperature was month wise, for production of grains was year wise. If I want to find out, say for example, flow of passengers through a certain airport, say for example, New Delhi, maybe Mumbai, maybe say for example, in Tokyo, Narita's airport, maybe in Frankfurt, maybe in New York, JFK, wherever you consider. So, there that can depend on many things. Say for example, if I am talking about certain, consider Frankfurt. So, obviously, there would be a set of people who are passing by through Frankfurt. I am taking Frankfurt as an example. They may be people who are landing at Frankfurt, and another set of people who are traveling out of Frankfurt. So, three sets of people are there. ending the journey there, starting the journey there, and in transit. So, if you check, maybe the hunch would be during the month of Christmas, starting November until about January each year, the amount of number of passengers traveling or utilizing Frankfurt airport would be the highest, because that is the time where holidays are there, people want to visit their near and dear ones internationally, nationally, and they want to domestically, and they would like to basically utilize airlines to travel. So, that may give you an idea that yes, there is a cyclicity rather than season, even though if I consider that festivity of New Year to be end of the month. So, because New Year it does not depend on seasonality, because if you consider the northern hemisphere and the southern hemisphere, the temperatures in these two hemispheres are different. In northern hemisphere, the end of the year would be in the winters, while I consider in Australia, New Zealand, it will be just the opposite weather. So, season basically is not affecting its cyclicity. Or maybe if I consider the concept of people arriving at Mumbai and during the holiday season. So, basically using the airport. So, people are traveling during Diwali, then traveling during Christmas, traveling during Dashera, traveling in Ganpati festival. So, obviously, you will basically find out different cyclicity there. Or maybe if we are considering the flow of traffic, I am only concentrating on the airports in Bengaluru. So, because that being the IT hub, and there the holidays being during the summers and the winters. So, many people travel in and around that city. So, obviously, that would be on a cyclicity. So, once you have defined the problem, you gather the data. So, it can be data related to, as I said, people moving, then can be rainfall, can be production, can be amount of tonnage of goods passing through Suez Canal or Panama Strait or Park Strait, if you are able to basically keep a note of that, or amount of number of ships and tonnage docking at Singapore shipyard or the port, similarly for Hong Kong. So, once you do that, you do a preliminary exploratory analysis. Exploratory analysis, what I said, was basically the idea how you look at the data, plot the data, have a feel, and we have discussed that. Then obviously, you have to basically check how clean the data is. Maybe some data points are missing, whether you want to basically have a good judgment and fill up those gaps. Consider this, and I will draw the diagram in order to make it a very simple one. Consider I have the data like this. So, whatever the data is, I am using the black color for the y axis, similarly the black color for the x axis, and consider x is some data you are trying to plot. So, this is dependent on time. So, let me put it as equivalent to time, because that would be much more easier for understand. And consider you are plotting basically x. X can be anything, whichever example we use. So, consider the data is such, let me use the red point, and the time frames, let me mark them as month. So, this is January, February, March, April, May, June. So, I will mark it 01 for January, 02 for February, 03 for March, 04 for April, 05 for May, 06 for June. This is just an example which I am giving. So, how you clean the data in very simple. And the data is available, which I am using now the red dot. See, for example, for January is available, February is available, March due to, say for example, you are not able to collect, April is available, and then May is available, June is available. So, the missing data is, which I will mark in green, is in the month of March. So, what do you do? So, a very simple analysis would be, say for example, I find out the average value in January, February is increasing. Then obviously, if I am considering this, then it again increases a little bit less, then it falls down. So, if I consider the trend to be increasing, what I can do is that I will use the color violet here. So, I consider the trend from 02, which is February, to 04 April is fixed. So, I will consider the March data to be here, such that I take basically the value of the height to the base, and this basically proportionally divided in order to find out what would be the approx value for the month of March, which means that I add up the value of February, add up with the value of April. So, consider for the month of February, it is, say for example, 22, and then for the month of April it is 53. So, I add up by and divide by 2. So, which means that this value which I have, in case if I want to be much more, so this would be the average value, and I want to find out the trend. So, 53 minus 22, which would be this height. So, that would come out to be 31, and what is the time frame? It is basically 2 months. So, divide by 2. So, if I consider approximately it is 50, approx 15. So, if the month of February was 22, then approximately for March it should be, this is an approx value, would be 22 plus 15, which comes out to be 37. Such that if I utilize this 37 value to basically find out for April, it will be 37 plus 15, it comes out to be about 52, which 52 and 53 exactly match. So, almost we are able to do that. So, this is a simple way of extrapolation. Another ways of extrapolation can be basically, if the missing data is there, you may basically try to utilize any nonlinear fit and try to find out. Another idea can be, say for example, we want to find out the idea that what was the variability. So, the variability would basically give us some information that how it can be used. So, if I am trying to basically utilize this, I will erase this and use another simple diagram. So, this is again I am drawing the y axis, x axis, and these vertical lines are the time frames, maybe month, maybe week. So, that is immaterial. So, consider the data set is just an example. One of the data points, this is y, this is x. So, this is time you are measuring, and the value x you are measuring on the y axis. X is basically the reading, y axis along which direction you are measuring. So, if I find out, can say for example, the data was like this. Say for example, the data is here, and it is for, which means if I consider the fit first month or first week to second week, first month to the second month to third month, or second week to third week. So, if I consider the variability here is fine, but suddenly there is a huge jump. So, maybe the jump is actually happening, you have to check, or maybe some error in reading. So, you have to basically omit that. So, that decision would basically come from the experience, a little bit more studies. So, this is basically cleaning the data concept which you are considering. Then another idea can be whether the variability is increasing or decreasing. So, this was aberration of the data. So, the variability is increasing, decreasing, we will see that how it can be done. You choose the appropriate model, whether you use the averaging techniques, moving average, exponential moving average, you first decide. And obviously, once you are deciding, you will have some metric to basically make a decision. And once the model is finalized, you will try to basically utilize the model for the future. We will see that later. And how good or bad this forecasting technique which you have utilized is able to predict for the future value is also important and part and parcel of the steps to be followed when you are doing the forecasting methods. Thank you very much and thank you for your attention. With this, we will end lecture number 2 for week 1 and continue the discussion further on from lecture 3 of week 1. Thank you.